Hi everyone. For this exercise we're going to be looking at the binomial test. We're going to be working through the same exercise that you can see in Appendix A4 of the Francis and Garing textbook. So for this problem we're using the What Analysis dataset, and we are interested in the proportion of, or the percentage of, married Australians. So in our data we can click on the variables button and we can click on marital status. We can see that we have this categorical variable. It's got variable values 1, 2, 3, 4, 5, and we're going to be interested in comparing the percentage or the proportion that are in group 1, married, compared to all the rest being collapsed together. So in order to do a binomial test, we can go up to Analyze, we go Non-Parametric Tests, we go Legacy Dialogues, and then we have Binomial. So our variable that we're interested in is marital status. Press the arrow or drag it across. For this variable, remember we had 5 different groups. We actually just want to compare group 1, which is married, with the rest. So by selecting a cut point, you are dividing your categorical variable up across the categories. So we're comparing category 1 to all of the rest collapsed together. If we had a variable which only had 2 categories in it, then we could just tick Get from the data. So one other thing we need to do, which is really important, is we need to type in the correct test proportion. For this particular example, what we're interested in doing is we're interested in comparing the value from 20 years ago, which was 71% of Australians being married, to our sample proportion of, or sample percentage of, people who are married in this particular sample that we have. So we are comparing to a test value of 71% or 0.71. It's really important that we enter the test proportion in here. If you just leave it, then all of your figures will be incorrect, and this is quite commonly the biggest mistake people make when they're doing the practical test. So then we can hit OK, and we get our test output. So we can see that 281 or 68% of my sample were in group 1, so married, compared to 135 people, which was 32%, who were not married. So my binomial test is comparing that 68% from our sample to our test proportion of 0.71. Our p-value is this very end box, so we have a p-value of 0.068. So remember that for a p-value to be significant, it needs to be less than 0.05. So this p-value is not significant. So not significant is telling me that I can't determine that there is actually a difference based on this sample between the 0.68 in my sample compared to that value of 0.71 from 20 years. So the other thing that we can do is we can go and use the confidence interval calculator on Blackboard to calculate the confidence interval for our sample proportion, this 0.68. So the key bits of information we need to remember: 0.68 is my sample proportion, and 416 is my sample size. So if we jump across to Blackboard and we use the confidence interval for proportions, our sample proportion was 0.68, our sample size was 416. So here's my 95% confidence interval. So what that's telling me is that I'm 95% confident that the population proportion of married people is somewhere between 0.64 and 0.72.